So I believe yesterday we ended here. Okay, that's as far as we got, right? Okay, so we graphed this cube root. For this cube root here, what would my domain be? Good, negative infinity to infinity. And my range would be negative infinity to infinity. Very good. Do I have any x-intercepts? Yes, I do. Well, I don't see them, but if I keep going, there will be how many? 1. There'll be 1. So I need to find that. That means I have to set 0 equal to the cube root of 2 times x plus 1 plus 4. Right? So then I subtract 4 from both sides. Negative 4 equals the cube root of 2 times x plus 1. So how do I undo a cube root? I cube it. So negative 4 cubed is negative 64. That's equal to 2 times x plus 1. Then what can I do? Divide. So I get negative 32 equals x plus 1. So x equals negative 33. No, that's a very good question. Well, we cubed it and we didn't take a cube root. That makes sense. But if I did take a cube root, then no. You only have to do the plus or minus if you basically if it's an even root, any even root, or any even root. Yeah, 2, 4, 6. But the odd ones, you can have the positive or negative. So my x-intercept then is negative 33, 0, which seems like a reasonable answer because it's, way out there. Then y-intercept. Well, I have one, obviously, but I don't know exactly what it is, so I have to find that as well. So that means I need f of 0. Well, f of 0 is going to equal the cube root of 2 times 1 plus 4. Well, can I take the cube root of 2? No. So it's just 0 and then cube root of 2 plus 4. The best I can do. Okay, we good? All right, do we have any critical points? Yes, what is it? Point of inflection. And so that is at negative 1, is that at 4? Am I increasing anywhere? Everywhere, right? So negative infinity to infinity. Am I decreasing anywhere? No. So there is none. Then as x approaches infinity, f of x approaches what? Infinity. And as x approaches negative infinity, f of x approaches negative infinity. All right. What questions do you have? We're good? All right. So good news is number 5 is exactly the same as number 4 because when I was cutting and pasting, I left something off. So we're just going to skip number 5 because we just did that one. All right. And let's go to number 6. I was going to fill it back in, but I don't think it's necessary. So we'll go here. All right. My parent function. What is this one called? Reciprocal. So f of x is equal to 1 over x. How many transformations do I have going on here? 3. Okay, because that negative counts as 1. So that negative, I know it means I have a reflection. So does that negative sign affect x or affect y? It affects y, which means it's a reflection in the x-axis. That 4, does that affect x or y? Y. So that means that this is going to be a vertical stretch by a factor of 4. And then the 3 is going to do what? Go left 3 because it affects x. Everybody okay with that? Okay. All right. Now, here's my little parent function. What does this parent function have that the other ones haven't so far? Asymptotes. So our asymptotes are very important. They're actually the first thing you want to get graphed. The only transformations that affect your asymptotes are the shifts. Only if you go left, right, up, or down. Any reflections, shrinks, whatever, doesn't affect these asymptotes at all. So I know that my asymptotes for my parent function are on the axes, right? So since all we do is shift left, we don't shift up or down, then the one that's on the x-axis is still on the x-axis. But the one that was on the y-axis shifts to the left 3, and it's now at negative 3. Okay, we good with that? All right, so now we're going to look at our anchor points. How many anchor points did we have here? There's just 2. We use the 1, 1 and the negative 1, negative 1, but I'll show you that we're actually going to get a couple more points on here, but in a very easy way. So we'll start with 1, 1. Okay, I'm at 1, 1, and I reflect in the x-axis, so it ends up down here. Vertical stretch by 4. My y value is negative 1, so I multiply by 4. My new y value is negative 4. And then I go to the left, 1, 2, 3. Then I'm going to start at negative 1, at negative 1, negative 1. I'm going to reflect in the x-axis, so it ends up right here. Vertical stretch by 4, 2, 3, 4, and to the left, 1, 2, 3. Now, remember how we said the reflection in the x-axis or y-axis, we would end up, the same thing happens, right? So let's just go back to 1, 1. And instead of reflecting in the x, we're going to reflect in the y. So I'm going to reflect this in the y. Then I'm going to vertical stretch by 4, and then I'm going to go to the left 3. You see how you end up in the same spot? That's why, because it kind of does. So I ended up here using 1, 1, and when I did it the first time, negative 1 is what got me here, but still I end up in the same spot, okay? But I still think that it's better for you to stay consistent trying to decide if it's an x or a y thing and answer it this way. That way you don't get yourself all mixed up. All right, so tell me about this parent function. Does the parent function have any kind of symmetry? Yes, it has point symmetry, right? It's a rotation in the, in the origin. Yeah, it's a rotation in the origin. It also has line symmetry in the line y equals x. And so that doesn't have anything to do with even or odd. But basically this line right here, if my graph was drawn nicely, couldn't I reflect it in that line y equals x? So since it has that symmetry, it still does after we stretch it and move it and whatever. So that'll give me a couple of other points. Because here, sometimes just having those 1 points is good, but I don't know how far, like how tight it's supposed to come in here, or if it swings way out here. Like I don't really know enough just based on where this one went. But since it has that symmetry, since this point right here, if I think of the orange, my asymptotes as the axes, right? So if I pretend like this is 0, 0, to get to this point, I went to the left 1 and up 4. Well, instead, if I go to the left 4 and up 1, basically that's a reflection in where that line y equals x would be. Does that make sense to you? So again, from the axes here, to get to this point, I went to the right 1 and down 4. So instead, if I go to the right 4 and down 1, that gets me the other point that's basically that reflection of it. So by having those 2 points instead of just 1, I can draw in this, and I know that it doesn't go super tight, but it also doesn't swing out super far. Okay? So it's just a matter of that symmetry there. Where by doing it that way, I get points that actually help me. If all I do is make a T-chart and start plugging in points, well, when you're doing that, you don't know if the points you're, like, what if I get like 5 points all right here? That's still not going to help me any, right? So by doing it this way and understanding it globally, you're able to kind of get the points that actually help you, all right? I had some people that were really having a hard time with how we were doing this yesterday, and I finally kind of figured out why, because I didn't know how else to say it again. But it was because they were so stuck on, why can't I just do a t-table? Why can't I just do that? Well, because it's not going to get you this graph like this. It's going to get you weird numbers that you're not going to be able to figure out without a calculator. And then when you graph them, it's going to be junk. So it's better, instead, you need to just know how to do what's happening transformationally. Okay, are we good? What questions do you have? All right, so let's run through this. We're not going to fill in all these on everything on the last two, but we'll do this on here. So my domain, is it all real numbers again? No. We go from negative infinity to what? Negative 3. Do I include negative 3? No, it is open. Then I have a union, and then it's negative 3 to infinity. If I put brackets around those negative 3s, that means I'm including it, so there's no reason to split it, so it wouldn't make any sense, right? Then range, I'm going from negative infinity to what? 0. and then from 0 to infinity. Everybody good with that? Do I have any x-intercepts? No, I do not. So there are none. Do I have any y-intercepts? Yes, okay. And I don't know exactly what it is. I do know it's negative, and it's kind of a, kind of a small negative number here. So but we're not going to guess. Like, it's good to kind of have an idea just so that, if your answer is reasonable. I need to find f of 0. So that's going to be negative 4 over 3, and that's the best I can do. So it's at 0, negative 4/3. Okay. So it's usually pretty easy to find, but you got to find it. Okay. Do we have any critical points here? Max, mins, points of inflection? No, there's none of those. Am I increasing anywhere? Yes, so definitely from negative infinity to negative 3. Is that it? No, and also from negative 3 to infinity. It's increasing the whole time, so which means it's not decreasing at all. So as x approaches infinity, what does y approach? 0. And as x approaches negative infinity, f of x approaches 0. Good. What questions do you have? Anything at all? We're good? Yes, we're good? All right. Flip it over. So here's another cube root, right? We've got cube root. So f of x is equal to the cube root of x. How many transformations do I have? 3, right? So I'm going to start with the negative. I know that means I have a reflection. This would be a reflection in what? The y-axis. Then that 1/3 would be what? Good. Horizontal stretch by 3 because x lies. And then that 4 means I do what? Up 4. Okay? Yes? All right, good deal. And then cube root looks like this. Sure, walk like an Egyptian one. So no asymptotes here. We can just start graphing. So I'll start with my anchor points. In this case, I'll start with 0, 0, right? So I'm going to start with 0, 0. And if you feel like you need to put the anchor points on the graph to get started, that's okay. You don't have to, and not everybody's going to want to. But I'm here at 0, 0. When I reflect in the y-axis, I'm still at 0, 0. When I stretch by 3, still at 0, 0. Then I go up 1, 2, 3, 4. Okay. So then the next one I'll use is negative 1 is my anchor point. I'm going to reflect in the y-axis, so I end up over here. Horizontal stretch by 3, so my x value becomes 3. And then I go up 1, 2, 3, 4. Okay. So I used 0, 0, negative 1, negative 8, negative 2 is my next one, right? And so I would reflect it in the y-axis, it ends up over here. When I horizontally stretch it by 3, my x value becomes 24. And it's not shifting back anymore, so I'm not putting it on the graph. Okay, like it's just not worth even trying because it's way out there. So I'll go then to, I need more than that. So I'll go to 1, 1. I think I can do something with that one. 1, 1. So I'm going to reflect it in the y-axis. I'm here. Horizontally stretch by 3. X value becomes negative 3. Then I go up 1, 2, 3, 4. Now, although my table just broke, okay, I'll fix it in just a minute. I'll just deal with it for now. Although these are the only 3 points that I can actually put on there for my anchor points, those other ones do tell me something, because the y value for that point that's way out there is going to be 1 below this one, right? And so that means I'm not coming down here like this to make my graph. It's going to have to be skinny like this. And the skinnier they are, the harder it is to kind of get that point of inflection in there. I can't even hit the points, but there we And so remember this. This is not an art class, okay? If you make an honest effort and it's clear you know you're trying to graph what you're supposed to be graphing, I'm okay with that. Okay, it doesn't look like you're trying to make a straight line out of it or something weird, like it's fine. But I want to see those points. I mean, I'm looking for specific points. If your curve looks a little wonky, it's not the end of the world, okay? As long as I can tell you, you tried. All right, any questions on this? All right, so I think you can fill in most of this stuff. Let's just find the intercepts here. Well, first of all, do you know what the y-intercept is? Yeah, it's 0, 4. That's nice because we actually found it. We don't have to calculate it. Then I need the x-intercepts. So that means that 0 is equal to the cube root of negative 1/3 x plus 4. Subtract 4, good. So I'm going to get negative 4 equals the cube root of negative 1/3 x. Cube it, so this is going to give me negative 64 again, is equal to negative 1/3 x. Good. Multiply both sides by that negative 3, so that means it's going to be positive. And then 3 times 6 is 18, so that'd be 180. 3 times 4 is 12, so it's going to be 192. And that seems reasonable considering we know how far that other one came. And it's 192. Any questions about any of the other blanks here? You don't have to go back and fill them in. I just feel like we could graph the next one and be done. Okay. So let's look at this one. What do we call this one? Reciprocal. Okay, so f of x is equal to 1 over x. How many transformations are there? 2. Okay. So that 2 that's in the denominator, what does that do for me? Good. Horizontal compression by what? 1/2. Right? And then what does the 1 do? Down 1. Okay. All right. Any questions about those? All right. Remember, don't be afraid to stop me if you've got a question. Okay. So let's graph this. This is my parent function. Looks like this. Right? And I need to get my asymptotes on there first. So I know they were on the axes. The only thing that affects them is the shifts left, right, up, or down. I didn't go left or right, so I still have one on the y-axis. The whole thing does shift down 1, though, so now here is where this asymptote is. Okay. Makes sense how to get them on there. You want them on there first because it helps you with the rest. All right, so then I'm going to start with 1, 1. That's my anchor point. I'm going to horizontally compress it by 1/2, so my x value is now 1/2, and then I go down 1. Boom, right there. Because we have a transformation where it shifts down 1, so since the whole thing goes down 1, the asymptote has to go down as well. So whatever the shifts are, left, right, up, or down, you do the same things to the asymptotes. The shrinks and the reflections don't affect them because they're lines. Does that make sense? All right, so then I'm going to do negative 1, negative 1. I'm going to horizontally compress it by 1/2 and then go down 1. Now, this having just 1 point, I think I can tell pretty much that it's going to be really skinny inside there. And I probably wouldn't have to put any more, but let's go ahead and talk about where they would be. If I'm using the asymptotes and pretending like that 0, 0, I go up 1 and to the right 1/2. So instead I go to the right 1 and up 1/2. And there's that little reflection there. And then this would be the reflection in y equals x there. So it's not like that other point really helps me that much, but I can find it anyway. So then I sketch that in. It comes really close to those asymptotes. Like so. All right, so then let's look at our intercepts. Well, I know what the x-intercept is, right? It is 1/2, 0. Do I have a y-intercept? Nope, none. And then the rest I think you're probably okay with, right? What questions do you have? Anything at all? Okay, good deal. Go ahead. Uh-huh. This right here? Okay. Okay, is the 3 inside the root or not? Okay, so the cube root of x over 3 like that? Okay, so what that would mean, that would be the cube root of 1/3 times x, basically. And so this would actually be a horizontal stretch by 3. Is that, yeah, okay. So anytime you have a fraction like this, where if you can break it up into something that looks like this, then it looks more like all the other ones you've seen, and sometimes it helps you wrap your mind around it so you're not doing weird stuff, because it can get confusing. Say that one more time. Uh-huh. Okay. Well, that wouldn't be a cube then, but like you're saying like if I have 1 over 3x. Okay, so what's happening is this is with x, so this would affect the x. If it's like this, it would affect the y. Okay? This is a compression of 1/3. This is a vertical stretch of 3. Okay? Those are good questions. What else you got? It has to be, because it's not sort of touching the x, but sometimes it's not actually touching it, or sometimes it is and it doesn't count. So let's say that so if I have this, technically that's touching x, but that is not a horizontal stretch or compression. That's a vertical because it happens after you square it. If I have this, that happens before I square it. This affects x, that affects y. So it's whether or not it happens before or after the function part of it, whether it's an absolute value or a square or a cube or whatever. So whether or not it's inside the parent function, like inside whatever that operation is, which changes for the parent function. Does that help? Okay. Anything else? Those are good questions. All right.